that we focused on rational numbers, let's take a look at irrational numbers. These are numbers that cannot be written as fractions. That's super important. They cannot be written as a fraction. So this is a non-perfect square. It's a decimal that does not terminate, or they don't repeat. A great example is when we think of pi. Pi is a number that goes on and on and on and on and on. So if I were to write out pi, I would say 3.1415, 9, on and on and on. I cannot turn this into a fraction, okay? So pi is a great example of irrational. If I said like the square root of 8, 8 is not a perfect square. I don't have a number that I can multiply by itself to give me the square root of 8. Another example would be the negative square root of 25. These are all irrational numbers. Now, taking this knowledge that we have, let's figure out how the number negative 3 would be categorized. Looking at the number negative 3 in this chart, is negative 3 a real number? Well, that is yes, so put a check there. Looking at negative 3, would negative 3 fall under the chart of a rational number or an irrational number? Well, since I can make negative 3 into a fraction, it is rational. Looking back at my chart, is it an integer? Looking at the definition of integers, that's whole numbers and their opposites. Negative 3 is a whole number, but it is negative, so it still is an integer. Is it a whole number? Thinking of a whole number, that's my counting numbers including 0. Do we ever go 1, 2, 3? Nope, I'm not going to be counting negative 3. It's also not a natural number, okay? And then is it irrational? It is not. Using this same example and the steps that we just did together, I want you to try to do the square root of 49. When thinking of the square root of 49, what two numbers that are the same can I multiply that would give me the square root of 49? That would be 7. Because the square root of 49 is equal to 7, I know 7 is a real number. It's also a rational number. It's an integer, which is a whole number, or the opposite, which means it's a whole number. When you're learning how to count, it comes natural, but it is not irrational. Great job. Let's move on to the third example here. I've got pi. We just talked about that pi is a real number. We use pi, but unfortunately it's not rational, which means it can't be an integer, which it's not a whole number, it's not a natural number, but it is considered irrational. Let's do one final example together. Here's a fraction. Seeing that it's a fraction tells me it is a rational number. I can make it in fraction form. Can I simplify this fraction though? 39 divided by 3 really equals 13. Seeing that the number is 13, I know that it is real. I know that it's an integer. It's a whole number, and it is a natural counting number. The only thing it is not is irrational. Go ahead and try to finish the rest of the chart, and we'll review your answers soon.